Hey everybody, welcome to Calculus 1. My name's Sean. I'll be your instructor for single variable calculus. This is Matt 271 here at Finger Lakes Community College. So I wanted to do a quick video just introducing myself, introducing the course, and the structure briefly of what you can expect in this class, why it's probably a little bit different than you've taken before. But this isn't going to replace reading the syllabus and going through the intro module, all that stuff. Just kind of a brief overview here. So we call calculus the math of change, and that's a pretty broad title because everything in the world is always changing. So to have a math of change, it's probably going to be a pretty grand thing, and it is. So the reasons for that we're going to get into in the course, but to just know that calculus is most likely tied to some of the bigger ideas in whatever discipline you're working toward or already a part of. Calculus studies and analyzes how things change, how things behave. And so you've done a lot of work to get to this course in pre-calculus and algebra before, studying patterns and functions that are kind of plain to see in the world. So things that grow with a percent rate of change, right? Exponential growth. Things that oscillate, periodic change. Linear functions, logarithmic functions, rational functions, polynomial functions. All of these things are kind of a set pattern. We can combine these things to mimic what we're seeing in the world and then use the power of calculus to analyze them deeper. And what we're going to see is that each function, as long as it's relatively nice, has its own kind of secret analysis built into it, and we get to unlock it. And it's kind of been there all along. So that's kind of the exciting part, and I won't steal too much of the surprise away from it. So a few of the big ideas I wanted to lay out from the course, as these are like the key kind of learning outcomes, if you will. So we have the limit, the derivative, integration, and the fundamental theorem of calculus. This is kind of like the 4 units-ish that we'll be covering. So just a brief bit about each of these. What is a limit? Well, a limit is breaking things down infinitesimally. So getting infinitely close to some single point, or thinking about something in the long run, right? Either running it towards the future or some infinite distance away, or running back into the past. When somebody says I'm thinking in the limit, they're talking about most likely a long distance trajectory of something. And so the limit, this idea of infinitely approaching, whether it be far away or to a single point, is kind of what allows calculus to happen. It's what allows the derivative to even exist. So let's just write down, what is the limit? We can say, long run thinking, but it's really this notion of approaching. It's probably the best one-word summary of what a limit is. It's approaching. So what is the derivative then? You've probably heard this word before. Like a derivative work of art is, from something, some original piece. Now we have this kind of secondary piece. And that's very similar to what you'll see of the derivative. But what the derivative really is it's the instantaneous rate of change. So how fast something's changing at an instant, which is actually kind of a paradox if you think about it, because you're talking about how fast something's changing. You kind of need a window of time. But we're going to unpack that logical paradox and why it's not really a paradox using limits. And that's kind of the big breakthrough of calculus, is exactly that point. So the derivative is the instantaneous rate of change. So how fast something's changing in the moment. And so obviously you'd be very interested in this if you're studying population growth. If you're talking about, creating some algorithm, and how fast you can drive down the computation time. If you're talking about, some sort of chemical process, we're very interested in the rate of change. Physics obviously is probably the number one application of calculus, but it does reach everywhere. This applies in the social sciences and psychology as well. With calculus drives all statistics. So just to kind of throw that out there. So that's what derivative is. It's finding the instantaneous rate of change in a very specific way, which we'll do in the class. Integration, you can think of this as slicing and adding. So slicing up a problem into infinitely small bits to make it to make something that's maybe more difficult into very simple problems. And using that notion of approaching, getting it to be infinitely small, cutting up a problem into simple pieces, then adding it back up again. And then these two things together, the derivative along with integration, you can kind of think of one as, as more differences and one is more adding or summing up. The fundamental theorem of calculus is connecting these two together. And that's the kind of the impact of it. And it actually didn't happen for a very long time. We had differentiation or the derivative and integration for a long time before the fundamental theorem of calculus arose. So we'll talk a little bit about the history of these things, not too terribly much, because a lot of what we want to get to is the nuts and bolts of how these things work and why they work, and you'll get that from this course. Before we get to limits, we're going to do a quick review on the kind of the library of function families, things we're going to be looking at, so polynomial functions, rational functions, trig functions, log functions, exponential functions, and the like, okay, linear functions. And then piecewise functions, and then all the combinations of those things, right? What if I put an exponential inside a trig function? What happens? Because that happens. These are interesting things. So we'll do a quick review of that before moving into applying calculus to these things. So it'll be a quick run of review at the beginning. There's going to be some places where you're rusty, and just make sure you're using the class discussion for help on those. And then lastly, I just kind of wanted to go over the structure of this class before this video gets too long. I will be creating lecture videos as we go. There will not be a lecture video from me on every single section, but I'm going to do my best to get as many out as I can. We are going to be working within this Lumen system. It is a math-friendly system, whereas most other LMSs are not, okay? So that's why it kind of looks different than Blackboard or if you've used other LMSs before. We still live in Blackboard in name only, but really all of our stuff's going to happen in Lumen. The reason for that is there's these interactive reading assignments that are highly developed, very, very nice. They're interactive, meaning that there's practice problems embedded in the reading. There are videos embedded in the reading with tutorials and little pop quizzes and stuff within. So it's very, very nice, and it's not your standard textbook, okay? It's a learning experience for sure. And this is kind of going to be the core of the content, in addition to the videos that I'm putting out. And then you'll have practice sets which come with tutorials. You'll have quizzes that, we've all taken math quizzes by this point. Then the other elements on our end will be community problems. So these are going to be via post, and there will be about 8 of them throughout the semester. And so about every 2 weeks, we'll jump into a problem together, get feedback from each other, make sure we're getting to see each other's perspectives. There's going to be different ways to tackle problems, and so it's really valuable to see your classmates do that, to also hear from me. And then you'll have a midterm exam and a final exam as well. And those are both cumulative because this is a sequential course, right? So for those of us going on to Calc 2, to make sure you're set up for success there. But just to kind of highlight that this is where the core of the course is going to be in these interactive readings. Don't be tempted to just kind of jump into the practice assignments. It's not going to go great. If you're taking calculus, there's a reason for that. You have to know this stuff in your bones. So jump into the readings, make sure you understand all that, and everything. I want this to all kind of feed into the class discussion. Obviously, you can't, talk about your answers to graded assignments like quizzes or exams or anything like that. But that the class discussion is really an analog for the classroom, right? And so I want you to feel that way and use it as such. So I hope that was helpful. Didn't go too long. It's under 10 minutes. I'll take it. But I hope you got a sense of who I am, what the class is going to be like, as well as a taste for the ideas of calculus and hopefully a little bit of the excitement of these concepts. So I hope you have a great start to your semester. Please reach out with any questions and take care.